The annual salmon run in British Columbia is a spectacular display of millions of fish moving from sea to freshwater to spawn.
It's still got some strength in its muscles.
What's even more remarkable is that traces of salmon also find their way into the vegetation that line the riverbanks.
Oh, do you see what I see?
Oh,
Look at this.
In fact, everything in this forest is intimately connected to a creature that doesn't even live on land. But with salmon numbers in decline, I wonder, just how far through this ecosystem are the effects being felt? The natural world is full of delicate and complex webs of interactions between species. But the slightest disruption can have major consequences. I'm Patrick Aryee, biologist and filmmaker, and I'm traveling the world to investigate ecosystems undergoing dramatic change, identifying the impacts and what aftershocks may be yet to come. The story of the Great Bear Rainforest begins out at sea, specifically the Salish Sea, a stretch of ocean off the coast of British Columbia. Its nutrient-rich waters, fed by freshwater streams and rivers, are home to a great diversity of marine species. We're out searching for one of them, a group known as the Southern Residents, or more commonly known to you and I as Orca. What makes these Southern Residents unusual is that their lives are shaped by their main prey, salmon. This affects not only their behavior, but even their anatomy.
trying to look around, see if we can spot any of these killer whales on the surface. Do you have like a killer whale song, an orca song, to woo them into the area?
My guides for the day are marine biologist Dr. Andrew Treitz and Josh McInnes. They monitor the health of both the southern residents and the salmon. These are two species that are deeply intertwined.
You see that tidal current right here? They're right in this current. Yes. So it's a little, you can see the color change in the water. And
The killer whale's favorite prey is Chinook, the largest of the 5 Pacific salmon species. The whales eat about 1,400 of these fish a day. Their relationship with salmon is so strong, they won't touch any other food. So what's going on here? How does the humble salmon hold sway over this magnificent ocean predator?
What is it about Chinook salmon specifically that makes them so nutritious?
One is it's just super big. And so you catch one, it's a meal to be shared, and residents share what they catch. It's also full of fat. When you're a marine mammal, there's nothing better than things that are high in fat, and they need that energy. And then the third thing is that, unlike a lot of the other salmon species, Chinook is available year-round. It's on the menu every day of the year.
But since 1984, the overall population of Chinook salmon has declined by 60%. And recent years have seen some of the lowest numbers on record. It's had a profound impact on the whale's numbers. The southern residents are now critically endangered.
Right there, there we go, turn around, boom. Right there. Wicked, this is it. This is perfect. So we were looking in the wrong direction. They're behind you. That is perfect. One, there's another one cresting onto the water. This is exactly what I've come here to see. This is the perfect place to come and see orca in their natural habitat.
There are as few as 74 southern residents left in the Salish Sea.
So you're looking at the dorsal fin.
Shape of the dorsal fin, and then the saddle patch is that whitest area in behind. We just saw it come up.
Like magic. One moment they're there, the next minute they're gone. That is just brilliant. I love the fact that we managed to get so close.
oh, there they are right there. Right over here, you can see this group of transient killer whales we have here are kind of going back and forth.
These orca are a different species. They're known as transients because they're constantly on the move.
Likely they may have found a seal or a porpoise.
In contrast to the residents, the transients have no taste for salmon, so there's no competition. And declines in salmon numbers have no effect on them. They only eat marine mammals, like seals. There's plenty of those, and unlike the residents, the transients' numbers are increasing. Salmon is crucial to the life of the resident whales, the region's top marine predator. But that's nothing compared to what the salmon are doing in other parts of this ecosystem. I'm heading upriver to the Great Bear Rainforest to follow their migration back to their birthplace to spawn and reproduce. The distances they travel are staggering. In some cases, thousands of kilometers. During their long journey, they undergo significant transformations. Some species go from silver to a deep red, with others turning completely black. This is one of the few places where their journey ends. The Atnako River, about 400 kilometers northwest of Vancouver.
We want to let the bears know we're coming and around some of these blind corners.
I'm teaming up with researchers Kate Field, Shanti Talio Milton, and Ron Schooner.
Looking for sockeye, they're bright red. It's a really popular spawning ground right here.
Their project is a collaborative effort between the New Hulk Nation, BC Parks, and the University of Victoria. They study grizzlies and their dependence on salmon. Just like killer whales, a grizzly bear's diet relies heavily on fish.
Shanti is keeping her eye out for carcasses, so she's got a fish counter here. She's counting carcasses, and whenever Ron and I see live fish, we yell out how many we see by species. We use those data to understand the time at which fish are most available to bears at the Atnako.
Nice.
Just a few decades ago, tens of thousands of fish used to return to these waters to spawn. Now, the count is as few as 2,500.
Look.
For this Chinook, it's the end of the road. He's one of the few fish that made it all the way here to begin the life cycle of the next generation.
I can notice that the condition of its skin is like really poor. It's starting to degenerate. What do you think of when you see a salmon like this?
I like to think about the journey that it's just had, really. I mean, they're just such adaptable and resilient species, and it's come so far just to get back to where it started, and to think that it's come this far and it's at its life end, there's a lot of respect there for an animal like that.
See what it feels like. Wow, you can see it's still got some strength in its muscles. It can move when it wants to.
Salmon is more than just the grizzly's favorite food. It's what makes the grizzly mighty. In the Great Bear Rainforest, bear populations are 10 times larger in areas with salmon in the rivers than in areas without. It's the salmon that sustain larger bear populations, and that has a cascading effect on every species that calls this rainforest home.
There's a nice carcass there.
Wow. Yeah. Can I pick that up? Are we allowed to touch on these carcasses?
If you want, I mean, I wouldn't recommend it, but yeah.
Take a look at that.
So you can see a bear has been foraging on the carcass here.
Oh, that stinks to high heaven.
Yeah. Yeah,
Oh, jeez.
there's a tail there. So
Oh, that is freaking horrible.
yeah.
Oh man, jeez.
The number of carcasses we see here hints at why wild salmon is the lifeblood of this region. It connects and feeds both the ocean and the forest, with bears acting as a go-between.
Oh look, there's a bear
Yeah.
right there.
Yeah. So right where we're standing. So here we have a non-invasive hair snag. They go over or underneath the hair snag, leaving us some of their hair.
The researchers use these hair snags to track bear numbers. The latest research shows that grizzlies are highly sensitive to changes in the salmon population, to such an extent that if a female doesn't get enough salmon to eat, she'll likely miscarry, meaning no cubs are born the following spring. And so salmon returning to these rivers in large numbers is critical to the bear's survival.
These samples, you're sending them to the lab, analyzing the DNA and getting a profile for each of the individuals that are coming through these areas.
We can also match these samples up with samples we collected in previous years to see if we're redetecting the same bears over time or what proportion of those detections are brand new bears.
The impact of salmon on the bear populations is just the tip of the iceberg. The fish also affect the streams they journey through during their migration.
How long have you been working with salmon for, John?
Just since I came here, actually. I used to study marine fish quite a bit in the UK. And so then when I came here, I was drawn to salmon because I didn't want to just study the fish themselves. I wanted to study the connectedness to everything else, right?
Right.
It was an excuse to study everything that is connected to them.
It was an excuse to basically come and chill here
Yep,
by the water
yep,
in the glorious sunshine.
indeed.
John Reynolds is a professor of aquatic ecology and conservation. He's brought me to a stream on the outskirts of Vancouver, where a bind of coho salmon are about to begin their journey.
Right there, moving around there.
Their babies are known as fry.
So that's a coho salmon. These are fish that were born in the winter, so they're going to stay for a year before they go out to sea when they're a little bit bigger.
That fish is so small, it's barely the size of my little finger.
Yeah.
How big will they be by the time they leave to go into the ocean?
By the time they go, they'll be about that big, so twice that size at least. And then they're going to be gone for about 2 years at sea before they come back, and they're going to come back this big. And they do all that growing in the ocean during this huge migration where they go and say hello to Alaska and come back down.
Like, so this gravelly substrate,
Yeah.
is that the kind of stuff that the adults are going to be trying to spawn in?
They'll actually want something a little more coarse because
really?
the eggs are big, which means they need a lot of oxygen, and which they're getting from the flow of water. So actually, this would be perfectly good here. They could dig their way into this, believe it or not. That's a little coarse, but maybe halfway between what you just showed me and this.
How do they know to come to this stream and not the stream next door? There must be some sort of chemical cue that we're not picking up on.
I mean, what happens is that they imprint on the chemical signatures of the stream. And to a fish, every stream smells different and tastes different according to what the rocks are and the substrate around the stream. And so they imprint on that. And we are quite a long way from the ocean. They have to make the correct turns to get to the right place. So it's just amazing to me that they can do that.
The magic of the salmon's influence begins out at sea, when mature salmon start their migration upstream to reproduce. Some are caught by bears, but most die a natural death after the spawn. When salmon die, their bodies decay and decompose into the water. This frees up a tremendous amount of nitrogen, which fertilizes everything around it. As amazing as that is, it's only part of the story. The gift keeps on giving beyond the riverbank. The salmon effect is so strong, it can be detected from space. After a big salmon run, the vegetation around the spawning rivers shows a more intense green and can be clearly seen on satellite images of the Great Bear Rainforest.
What are the indicators that you would be looking for?
Well, this is a good example here. And so this is the well-named salmonberry. And this species actually loves salmon. This is more dense in streams that have more salmon. And that they actually produce more berries, which look like big fat raspberries. If you took me to a stream where I had no idea how many salmon there are, I would have a pretty good idea by looking at the plants, and I could at least say no salmon, medium number of salmon, or tons of salmon. It is actually quite striking.
What seems to be happening is that the vegetation is getting an extra boost of nitrogen, a substance that promotes growth.
So when you buy fertilizer for your garden, a huge component of that is nitrogen. Although it may look really lush and green and so on, nitrogen is limiting in a lot of these kinds of streams.
To find out where it was coming from, John and his colleagues collected leaves from salmonberry and other plants. They tested them for a naturally occurring isotope of nitrogen, N15.
We use that as a marker, basically a tracer, for whether it came from land or whether it came from the ocean, because it's more abundant in the ocean, and it's especially more abundant up through the food web. So it gets higher and higher levels as you go up and up and up.
N15 isn't usually found in the rainforest, and so John's team suspected it was being brought here by the salmon, which accumulate N15 in their bodies while out at sea.
Salmon are pretty close to the top of the food chain, so when we see huge amounts of N15 concentrations in leaves of plants like this, then it's pretty easy to point the finger at the salmon as the source, because they've come from the ocean and they're pretty high up the food chain.
My journey down the Atnarco River continues. The peaks we see around us are the Coast Mountains, a range that extends from the Yukon in the north all the way south to Vancouver.
Oh my God, look at that. Epic views right here. Low-lying cloud, and the sun peeking out is just magical. And somewhere hiding here are grizzly bears.
My guide is Hayden Parker. He knows this river system like the back of his hand.
This river here, the Atnarco, is about 60 kilometers of the most productive spawning grounds in the Vellicula system.
We're headed deeper into the Great Bear Rainforest to understand just how far the salmon effect extends.
Think that's a Chinook?
Yeah, spawn Chinook.
Wow. Well, it's going to take a few days before it dies.
Yeah, its systems are shutting down. Once they hit the fresh water, all their energy goes to sexual reproduction. That's why its skin is all mottled like that. It just hasn't regenerated any new skin cells since it started its migration. All salmon spawn. It's part of their cycle.
This Chinook will have burned up to half its body weight just getting here and spawning. It can still weigh up to 22 kilograms at this point in its life cycle, the same as a baby bison. There are few animals in the rainforest that can lift this kind of weight.
There we go. Take a look at that. We've got some paw marks from a bear. You can imagine one of these big grizzlies catching a salmon and then coming into the shallows here to just rest and just gorge on all of that goodness. So we've got all the signs here. We've got paw marks. We've got salmon that are basically living the last moments of their life. But still yet to see a bear. Pink salmon numbers are down by about 2/3. And the bears realize this. Not enough. There we go, right there, right there. This is the first bear that we've managed to see up close.
I'm gonna get on the other side of the river and get to the beach to give him some space to fish.
Yeah. Look at that nose, sniffing the air.
He didn't like us.
And we can tell that it's a grizzly bear by its shape, that characteristic hump on the front of its shoulders. That just going, slipping gently into the water. and it's just gonna have a quick look for these salmon.
What happens next is where things get interesting. If you think of nitrogen as cargo carried by the salmon, the bear is taking it from the river and unloading it onto dry land.
Because there's so many dead fish in the river, the bears have a lot to choose from. So they're sort of just taking the nicest bits. They're peeling the fillets, the skin, sort of the most nutrient-dense, high caloric intake. This bear's probably just gonna finish that skin, leave the rest of the carcass, go find another fish with, you know, a fillet on it or a piece of skin, eat that, leave it again. So you'll see a lot of these dead fish that have been kind of eaten by a bear but only picked at.
This one here. Oh my gosh, okay, that's cubs there. That looks like a young cub.
Within seconds, the situation does a complete 180.
We should be careful there, right? There's a young one there.
We've gone from observers to participants in a flash.
We're kind of caught between a rock and a hard place. We've got solitary male just behind me, and then to my right we've got a sow, a female, and what looks like one cub.
This isn't exactly an ideal situation to be.
Yeah.
It's probably a good idea just to give them their space.
Look at that, she's staring down this subadult.
So we'll just hold back kind of the 40, 50 meter mark and let this whole scene play out.
We've got a big mama bear, and she is snorkeling right now looking for fish and effectively teaching her young cub how to feed itself during this period of time. Look at that little cub. This is great. This is exactly what I'm here to see. These animals doing their thing, and they're here for salmon. They're here to feast.
My journey to understand the impact of salmon wouldn't be complete without a stop here. The Bella Coola Valley, located at the heart of the Great Bear Rainforest. It's home to the Nuxalk Nation, an indigenous community of the Pacific Northwest. The salmon come through here on their way to spawn in the rivers further up the valley, a fact that has shaped the lives of the Nuxalk. They call themselves people of the river. Both their culture and their economy have been shaped by salmon for thousands of years. Nuxalk artist Alvin Mack knows the salmon effect well. It makes the cedar trees near the rivers grow so fast and big that surprisingly, they're unsuitable for his artwork. But why?
When it does grow beside the river, it grows rapidly. So the grains are way thicker.
They're not as easy to carve as the ones that may be more inland, away from the river areas.
Yes.
Okay.
So it does show how much bigger and how richer the soil is by the river. There's the raven here, and there's the raven transforming.
That's pretty spectacular. So these totem poles, as we would call them,
yeah,
they're story poles.
A story pole, that's right. All our carvings, all our masks had a story behind it. And that was done for 15,000 years. We're still telling those same stories.
I would love to help you somehow. I don't know if that's allowed.
Try it out anyway.
Alvin, I don't want to ruin this.
No, we can always fix it up, but go ahead. We're all watching, just remember.
I know. 15,000 years worth of heritage, like gone in just like 2 seconds. Okay, so.
So what I do is I'll set my blade down here first, right about there. Then this one, you just kind of anchor it. Now you push and pull the same time. There you go.
There we go. So
There,
I'm slowly
yeah.
kind of getting the hang of it.
The animals in Alvin's story poles come from Nuxalk mythology. The grizzly, the salmon, the whale. They're all telling the story of the salmon effect. a story that Alvin's ancestors have always known and always included in their traditional art.
In the final stages of finishing a story pole, what do you do to the actual wood? Do you put any kind of lacquer or anything to treat the wood?
We'll take this rock and we'll boil it, and then we crush it, and then it turns to the powder. Then we would take dog salmon eggs, and we take the inner bark of cedar bark, and we'll chew that. We'll chew the eggs and the bark together and spit it into the powder. Then we mix it up, then we paint. But if you think about it, there's paintings all over the coast there that we've painted on rocks. And some people have painted over them with commercial paint. Commercial paint falls off in a couple of years, but our paint is still there. 5,000 years ago, that's all we had, and we made sure we made use of it.
The Newholk Nation have known about the gifts salmon brought to their land since time immemorial. But scientists have just started to understand it. They now trace its effects way beyond the riverbanks, sometimes almost a kilometer deep into the forest, where bears unload their cargo of nitrogen.
Hey, bear.
To help me figure out what's going on, I've called on my friend and colleague, Dr. Ray Wynn Grant. She's a large carnivore ecologist who specializes in bears.
You have to get a little low here.
The Newholk call this part of the Great Bear Rainforest Grizzly Island. It's a triangular strip of land, barely 20 square kilometers, with salmon rivers bordering two of the sides and towering mountains on the other. And as its name suggests, it's home to an incredible number of grizzlies.
So we're walking the path of a bear, can you tell?
Yeah, you can see that all of this grass here has been
Just mowed down. It's like a highway, but keep your eyes peeled again for, oh, do you see what I see?
Oh,
Look at this, fragrant.
Bears are by far the largest predator of salmon in the rainforest. A single grizzly can eat up to 34 kilograms of salmon a day. That's a lot of fish and a lot of nitrogen. They'll often carry their meal deep into the forest to enjoy out of sight of other bears.
oh, look at this.
Oh, do you know what this is?
That looks like the impression of a bear's butt.
This is a bear bed. There are estimates that one bear could bring 700 fish from the shore up into the forest.
That's a lot of
in
fish
one season.
for just one bear.
Yeah, and so just think about all the bears here. I mean, that's tons and tons, literally tons of fish being deposited in this earth.
It's clear that bears are the main conveyor belt moving nitrogen into the forest. But they're only moving it a fairly short distance. We know that nitrogen is traveling much further than that. So, how's it getting there?
This is a little more of the same, but
So this is just, looks like it's just skin here.
yeah.
And also, what's that?
Also,
Massive poop right
it's a nitrogen deposit.
What's interesting about this bear scat isn't just that it's full of salmon nitrogen. It's also full of seeds and partly digested fruit, like blueberries. That makes it the perfect treat for small rodents like deer mice. They eat the seeds, spreading the nitrogen even further into the rainforest.
Hey, bear.
But even that's not the end of the story. A whole bunch of even smaller creatures also help to keep this vital nutrient moving.
Are you ready for this?
Oh, that's disgusting. Look at that. It,
Yeah,
it
look at
looks
these
like
teeth,
it looks like
right?
a zombie fish. Look at all those maggots
Oh,
there.
yeah, we got like a little bit of eyeball or brain sticking out.
Look at all of that. That is
Zombie
absolutely...
fish because it's dead, but it's alive at the same time, right? These maggots are going to turn into flies that are going to be eaten by the birds and by actually some of the baby fish that actually hatch right here.
Yeah.
So it's like this fish died and sacrificed its life
almost for the next generation of salmon. That's how I think about it, at least, and I think it's really nice.
Insects aren't the only winged creatures taking an interest in salmon. The bald eagle is a fearsome hunter, but it also scavenges, and its favorite meal is salmon. Eagles will even synchronize their migrations with the salmon run. Whenever salmon spawn, the eagles show up in large numbers to feed. Bald eagles are known as sea eagles because their feet are adapted to make it easier for them to pick up their slippery prey. By moving nitrogen from the ocean into the rainforest, all of these species are supporting players in this great drama. The story of the fish that built the forest. But even that isn't the complete picture of this interconnected system. There's one more piece of the puzzle I'm yet to explore.
This is an old tree here that is now decomposing, it's rotting. And one of the things that helps this to break down are fungi. And what you and I are most used to is seeing something like this. Now look at that. That is beautiful. But the majority of the fungus isn't in the fruiting body, it's in the ground, in things like decomposing trees, underneath the ground, beneath my feet. And it forms this really deep, intricate network, a mycelial network that is constantly sucking nutrients up from the ground.
I'm a forest ecologist, and so I'm always looking at relationships and connection in forests. And
Suzanne Simard studies how trees distribute nutrients through an underground network of fungi. Her works even inspired a Hollywood blockbuster, James Cameron's Avatar. Her research has changed the way we see forests forever.
I knew that the way we understood forests wasn't complete, and we're so focused on what was going on above ground. And so I thought, okay, we've got to look at what's going on in the soil. So I started looking at the fungi. There's 55,000 species in the world of fungi. And they do so many different things. Some of these fungi will link this beautiful hemlock tree with the other hemlocks in the forest.
So they're all connected?
So they're all connected.
But not through their own root system?
No, it's the fungal threads that will join trees of different species of the same species. And literally there are hundreds of species of fungi below ground that are weaving together in these intricate webs. It's like a tapestry down there, really.
So the trees are photosynthesizing way up there, drawing all those nutrients down, storing them in the roots. And what are the fungus doing? Are they accessing nutrients that the trees can't access so readily?
The mycelium uses that sugar to grow through the soil and pick up nutrients and water and bring them back to the tree, and then they exchange them in this beautiful mutualism.
The trees are also using fungal networks to exchange salmon-derived nitrogen-15. These networks are like natural pipelines. They move nitrogen from trees with a lot of it to trees that have less. But they do a lot more than just share food. Trees communicate their identity and learn that of their neighbors and whether they're related. They even communicate information about their health.
Enzymes, for example, are produced when one tree in this network gets injured, or maybe it's dying because it's getting old, or it's been infected or infested by an insect. And it will send a cascade of responses through these networks to the neighboring trees. And those trees that receive that enzymatic message actually upregulate their own defense to that insect or pathogen.
That is genuinely incredible. That, to me, is definitive proof that these trees are effectively talking to each other. Is there any way that we can actually see these networks?
Yeah, well, hopefully we can. If we can come over here a little bit.
You're on the move. Keep up, boys. So we've got a shovel here.
Actually, I think I can just pull it back with my hands.
Almost like a carpet. How about here?
Yep, those
Is that
little
it?
threads.
There,
Yeah, there we
boom.
go. This is a big, long fungal thread.
Nice.
Yeah.
You can see how we just have to move some of the detritus away.
Yeah.
And look how it's just
Yeah.
spreading.
It
That's
goes
just
so
one.
far. This one is what we call a runner hyphae. And so its job is to actually run through the soil like a pioneer and find that next frontier.
Look how far it's going.
Yeah, it's incredible, hey? It's like a big telephone line.
It is, just like an old school telephone line. And that right there, that cable is connecting communication
These trees
network.
together.
These big trees, they're feeding these younger plants.
Exactly. We've sort of viewed them as very simplistic in the past, but now we know that their societies are as complex as our own. Their relationships between each other are as sophisticated as ours are between each other.
If the impact of this intricate network is as powerful as I think it is, could it also be felt in one of the most inaccessible places in the rainforest?
Whenever you're ready. Ooh. Lots of little steps up. That's all it takes, just lots of little ones. Perfect.
This is my chance to see if the effects also reach up to the uppermost layer of the rainforest, the canopy.
Nice. Okay, so I just got up to the first set of branches. These trees are also providing a habitat for a number of different animals and species. And just here, these branches are perfect for any number of birds, maybe even an eagle. I'm only halfway though. Let's see if I can get up there. Coming up into the upper canopy.
The canopy is where trees do most of their photosynthesis, using sunlight to produce ATP, the chemical energy that sustains life.
So we've got lichen, little spaces for insects and vertebrates. Always liken trees to Mother Nature's skyscrapers. And they really are. It's like different apartment blocks, and as you get higher and higher, you notice different things. Got some leaves falling down on me. There we go. Well, it gets a bit tricky up here. Whoa.
Rod's coming down!
Nice.
From up here, I can see that a salmon river runs nearby. So this Douglas fir tree, that's at least 350 years old, should also be impacted by salmon nitrogen.
100 feet off the ground. Take a look. It's a long way down. Look at this view.
Salmon are the key to this biome. And the spawning season has ripple effects that impact countless species. We're only just learning of the extent of these wild connections.
These salmon are nourishing and feeding this. And it's pretty amazing, isn't it? There we go. That is what I've come all this way to get a hold of. And locked inside every cell is nitrogen-15. And that nitrogen-15 hasn't come from any land-based animal or other plant. It's come from the ocean.
In my journey through this ecosystem, I've tracked salmon From the Salish Sea, along the streams and rivers, and deep into the heart of the rainforest. We followed their nutrients, transported through grizzly bears, eagles, and mice, up into the trees that are fertilized by their nitrogen. And below, in the soil, we've discovered that nutrients are dispersed through a fungal pipeline system. It's an invisible interconnected web that maintains one of the planet's most unique ecosystems. The Great Bear Rainforest is an unforgettable, remote wilderness that leaves you captivated by its natural beauty, but also by its remarkable connections, including the people that first came here to start a relationship of balance with the river and the land. We've made our way back to the foothills of the Bella Coola Valley. Our exact location is a secret. Very few outsiders are permitted access to these sacred paths.
Salmon also come up this creek.
Clyde Tallio, a New Hulk historian and linguist, is acting as my guide.
Almost here now. Okay. We'll just get to the top here.
And this is what we've come to see. These petroglyphs are thought to be between 5,000 and 10,000 years old, older than the Great Pyramids of Giza. It's been a sacred site since the ancestors of the New Hulk first arrived here.
What you're seeing here is the first ancestors coming to this earth.
They remind me of almost like hieroglyphics from the ancient Egyptians.
Yeah. Each symbol that you see will tell a different part of our history. Now this is my favorite spot. See the orbs above the dancer's head. When you ask the old people, what's the meaning of life? They will say that one word, staliwa, to have a full human experience. We're meant to laugh, to cry, and each time we do, we add that to our spiritual basket.
Catching sight of the next set of images, I'm struck by just how familiar they appear.
You see the grizzly bear's face, face of Nun. Nanak, the paws of the bear. And then here is the sumpt, the salmon. And you see there's his head, his tail, and he's eaten right down to the bones. Kind of sums up your journey, the life cycle, the connection.
The Great Bear Rainforest is one of the world's last coastal temperate rainforests and a natural treasure. The land, sea, and freshwater ecosystems depend on fragile bonds for their ecological integrity. Although fluctuating salmon numbers are a cause for concern, Indigenous communities and scientists are working hand in hand to monitor and protect this landscape in the hope of preserving this natural wonder for generations to come.